Hello class, in this video I'll be discussing mass relationship in a chemical reaction. So we're done with mass mole particle relationship. So this time we'll be converting these quantities in a chemical reaction. Okay, so it's important to understand the mole and mass ratios. Okay, then later on I'll be creating a new video for limiting reagent, percent yield, and theoretical. Okay, so calculating reactants and product. So as mentioned in the previous video, so we identify the amount of the products depending on the available reactant. So basically, when you're cooking, you will know how many servings based on your ingredients, right? Okay, so you can also calculate that using the chemical reaction. So for example, to form an ammonia, we have here nitrogen gas and hydrogen gas. But we have to balance the chemical reaction so that we know what is the ratios between this. So to balance, we use the REP or reactant element product. So the elements are N and H. So have here 1, 3, 2, 2. So we have to balance the H. So we multiply this by 2. This becomes 2. This becomes 6. Then to balance the H, we multiply this by 3. So this becomes 6. So the balance equation will be 1 is to 3 is to 2. So the ratios will be 1 mole of N2 is to 3 moles of H2 is to 2 moles of NH3. So basically, whatever the coefficient, numerical coefficients, that will give you the ratio. Okay, so so the balance equation shows you the ratio between each substance, or this means that the coefficient, so you have here 1, this coefficient shows you the number of moles of each substance. 1 mole of nitrogen gas, 3 moles of hydrogen gas to form ammonia. Okay, so we'll use that to solve for certain amount of substance. Of course, it will not always be in whole number. Okay, so let's try. So to solve that, to solve the problems involving this, you have to know the mole ratio. So the mole ratio is basically this. So we have here 3 moles of this is to 2 of this. So you can write this as 3 mole of each over, or you can have it this way, as long as the ratio between these are correct based on the balance equation. So to solve that, basically you're just canceling out units, and take note that for you to convert from substance A to B, you'll be using the mole ratio. Let's show that. Okay, so here is the problem. So ammonia, leading industrial chemical used in production of agricultural fertilizer and synthetic fiber. It's produced by the reaction of nitrogen and hydrogen gas. Question is how many moles of NH3 will be produced if 10.4 moles of H2 reacts completely with the N2. So that means you have to identify, based on the given, you have moles of H2, and we have to convert this to what is asked, 2 moles of NH3. Okay, so take note that, I'll write it here, if you are converting grams to mole or mole to grams, you'll be using molar mass. Okay, but if you're converting mole of A to mole of B, you have to use mole or molar ratio. This will be coming from the balanced equation. Okay, from balanced equation. Okay, let's show that. So this one is conversion of mole of A to mole of B. Mole of A to mole of B. So we'll be using, use molar ratio. Okay, so you write first the given. The given is 10.4 mole of H2. So you have to convert H2 to mole of N2. So you have to multiply this by mole of H2, mole of N2. H2 in the denominator so that you will cancel it. What will be the values here? So mole, so that molar ratio from balance equation. So this is 1, this is 2. And this one, it should be NH3. Okay, so that means we have 3 is to 2. Okay, then we multiply that. So that will be 10.4 times 2 divided by 3. So 6.93. 6.93 mole of NH3. Okay, so cancel. We have mole of NH3. Okay. Okay, next. Same chemical reaction. How many grams of NH3 will be produced in 25.7 mole of N2? Okay, so we write first the path. So that means you have to convert moles of N2, then convert that to mole of NH3 before you will be able to convert that to grams of NH3. Okay, so you always pass through this, the mole of A to mole of B before you convert that to grams. Okay, so let's write the given. So that will be 25.7 mole of N2 multiplied by mole of N2 in the denominator so that you can cancel mole of NH3. This is mole ratio, so molar ratio. So you get that from the balance equation. So NH3 is 2, 2 is the 1. So 2 is the 1. Again, that is coming from the balance equation. Okay, then we can cancel out this. But then we have to convert the mole to grams. So we'll be using another conversion factor. Mole of NH3 on the numerator, gram of NH3. So this is gram to mole. So that means that is a molar mass of NH3. So I have to get that first. Molar mass. NH. We have 1, 3 times 1. What is nitrogen? 14. So that will be 14, 3, so 17 gram per mole. So we put here 17, and then we have here 1. Then we can cancel out mole, mole. Okay, so we have now the molar mass. So to input that in our calculator, we'll have here 25.7 times 2 times 17 over 1. 873.8. So that will be 873.80. The unit is grams of NH3. Okay. 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 Next, number letter C. How many grams of NH3 will be produced if you have this, and then we're looking for grams of NH3. So for you to go there, you have first grams of N2. You have to convert this to moles of N2. Then from mole of N2, you'll convert that to mole of NH3 so that you can convert that to gram of NH3. In this case, you'll be needing the molar mass. This is mole ratio or molar ratio. And this is also molar mass. Okay, so let's get first the molar mass of what we will be using. N2 is equal to 28 gram per mole. NH3 equal to 17 gram per mole. Okay, these are molar masses. So it will be easier to convert that. But sometimes you will not use it. That's why it's just, molar mass. Okay. Okay, let's have first the given. The given is 122 gram of N2. So we have to cancel gram of N2. So we put it in the denominator, then mole of N2 here. So that will be 1 mole, 28 grams. Okay, then cancel. Then we have to cancel the mole of N2 and convert that to mole of NH3. This is mole to mole, so that's molar ratio from the balance equation. So NH3, 2, and then N2 is 1. So 2 is the 1. So 2, 1. Now we cancel this. Then we have okay. We cancel the mole of NH3 because we need the grams. So meaning we're using the molar mass, so that's 17, then 1 mole. Okay, so that is coming from here. Then we cancel this. So we have now grams of NH3. So solve that. This is our calculator. So you put everything on numerator, then divided by 28 times 1. So that will be 148.14. 148.14. And now the unit is gram of NH3. Okay. So those are examples. Okay, let's have another example. You can just pause the video if you want to. Next, given this equation, how many moles of O2 are produced in 6 moles? Step 1 is to balance first the reaction. So we have KClO3, K, C, L, and then O. So we have 1, 1, 2, 3, 1, 1. Okay, so we can multiply this by 2. We multiply that by 2, this becomes 2, 2, 6. So we multiply this by 3, this becomes 6. Then we multiply this by 2, become 2, 2. So 2, 2, 3. Okay. So, okay, I'll just rewrite it here. 2 KClO3 yields 2 KCl plus 3O2. Okay, now we're looking for how many moles of O2 are produced by the decomposition of 6 moles of potassium chloride. So potassium chloride is KClO3. So that will be mole of KClO3 to moles of O2. Mole to mole, so molar mass. So 6 mole of KClO3 multiplied by, we have to cancel mole of KClO3. So we put that in the denominator. Then mole of O2. Then we get the values in the balance equation. So that is 2 is to 3. So 6 times 3 is cancel. 18 divided by 2, so 9 moles of O2. Okay, so we use that. Okay. Next, what is the mass of the potassium chloride? What is the mass of potassium chloride needed to produce 2.50 mole of oxygen? So that means the given is mole of oxygen. 2. Mass is grams of KClO3. So we start with the mole of O2. So 2.50 moles of O2. We have to convert this to mole of O2 and then mole of KClO3. Mole to mole, so that's from balance equation. 2 is to 3. So 2 is to 3. Then we cancel this. Then we have to convert the mole of KClO3 to grams. So we need mole of KClO3 to grams of KClO3. Gram to mole, so we need the molar mass. So we get first the molar mass, O3. So that will be 3 times 16. Chlorine is 35. Potassium is 39. So what will be the sum? 39 plus 35 plus 48. 122 gram per mole. So that means be 1 mole, 122 gram. Okay, so that will be equal to 2.5 times 2 times 122 divided by 3 times 1. So 203.33. 200.33, and the unit is grams of KClO3. Okay, so this one was used to solve for the mass. Okay, so but this one is the answer. Next, calculate the mass in grams that can be obtained from grams of KClO3. So that means we need the following: grams of KClO3, convert first to mole of KClO3, 2 moles of oxygen gas to grams of O2. Okay, so we need these conversion factors. So we start with the given 46.0 grams KClO3 multiplied by gram of KClO3, then mole. How will you know which will be placed in the denominator? Take note that you have to cancel this, so it should be in the denominator. Okay, so for every 1 mole, we get the mass. The mass is 122. So 1 to 2. And then we have to convert next the moles of KClO3 to moles of O2. Mole to mole, so that is from balance equation. So what is the ratio? Oops, wait. And wait, copy. Okay. So the balance equation is this. So we have 2 is to 2. 3 is to 2. So 3 and then 2. We cancel this, but we still need the grams. So now we have mole of O2 and then grams of O2. For every 1 mole, so we have to get the molar mass of O2. Since O2 is oxygen, O2 is 2 times 16. That will be 32 gram per mole. So we need 32. Okay, cancel, cancel. So we have now grams of O2, which is asked, mass of O2. Then calculate that. 46 times 3 times 32. 122 times 2 times 1. So we have 18.10. So that's 18.10 grams of O2. Okay. Okay, so those are some examples. So you will be needing, most of the time, you have this, the balance equation, and the molar mass of whichever substances are required. Okay, there. So for your practice, here's the solution. Try to answer this. Okay, step 1 is to balance the equation and then do the conversion. Okay,